In this video, we will talk about how we can draw conclusions from an if-then statement. So I want to begin with an example right away, which says, let S be the proposition that if x is less than 15, then y is greater than or equal to -2. And suppose this proposition S is true. This is a true statement. Determine whether the following sentences follow logically from S. Part A is the statement. If x is equal to 10, then y is not equal to -30. So I want to explain this in two ways. First, I want to give an intuitive reason. And then we'll give a more technical reason. So for the intuitive reason, based on what we are told is true about this implication, we know that when x is less than 15, then y is going to be greater than or equal to -2. So I'm just organizing my thoughts into bullet points here. So here's the first thought. Based on what part A says, we are now given that x is going to be equal to 10. Because it says if x is equal to 10, then y is not equal to -30. So we are now going to be given that x is equal to 10. And because x is equal to 10, that definitely falls under the category of x being less than 15. So this means x is less than 15. And because x is less than 15, that means y is greater than or equal to -2. So thus, y is greater than or equal to -2. Therefore, it's impossible. If y is greater than or equal to -2, it is impossible for y to be equal to -30 because -30 is way smaller than -2. So it's impossible for y to be -30. So we do get to conclude that y is not equal to -30. So that means this statement, let me just call it A, logically follows. This logically follows from the proposition we started with S. Okay, so that's sort of an intuitive reason for why this is true. I also now want to give a more technical reason. So for this, I really want to break down the structure of S. So S is an if-then statement. So the if portion, I'm going to call this P, and then the then portion, I'm going to call that Q. So P is x is less than 15, and Q is y is greater than or equal to -2. So let's look at this technical reason now. And in the technical reason, I'm really going to analyze, well, what does it take for an if-then statement like this to be true? Because it tells me it's supposed to be true. And for that, I'll look at the truth table. P, Q, and then P implies Q. So we've seen this one before. Q will alternate true, false, true, false. P, double truths, double falses alternating. And the only way for the implication to be false is if P is true and Q is false. If the first part is true and the second part is false. In all of these other rows, the implication is true. So in this problem, we are given that S is true, which is the if-then statement. P implies Q is true. So we only want to look at the true rows. So which are the rows that ended up with the true? This one, and this one. We're only going to be looking at those rows. And what are we given now in part A? We are given that x equals 10. So, and if x is equal to 10, that means P, which is saying x is less than 15, that means P is true. If x is equal to 10, then x is definitely less than 15. So P must be true, which means Now I got to look at, out of these 3 rows, which one of them have a situation where P is true. And it's just this one. Out of those 3 rows, I'm ignoring the second one, because in the second one, the implication was false. And we're given in this problem that S is true. Okay, so we know that we're looking at that first row now. All right, so because of that, this must mean that Q is true, because now we know we're in the first row. So if Q is true, that means Y is greater than or equal to -2, because that's what Q is saying. All right, and if Y is greater than or equal to -2, therefore, we can now conclude that Y, if it's greater than or equal to -2, it's definitely not equal to -30. So we reach that same conclusion this way. Well, this one is more of a technical way to argue it using truth tables. Okay, so I want to use this truth table now to say something about when can we conclude things from these if-then statements in general. Okay, so in general, let me zoom it out a little bit so I can still look at my truth table while doing this. A little bit more. Okay, so in general, if my implication P implies Q is true, and in addition, P is true, that means we're in the top row. The whole implication is true, and P is true. That's the one that we just did in this example. Then we can conclude there, then that means that Q has to be true. So if P implies Q is true and P is true, that must mean Q is true. On the other hand, if P is false, that could either mean I'm in the third row or the fourth row. And in that case, I can't tell whether Q is true or false. Q could be true or Q could be false. So we are inconclusive about Q. So now suppose Q is false. So again, the implication P implies Q is true. So we're only looking at the first row, the third row, and the fourth row. And if Q is false, that would leave us to be in the fourth row. And if Q is false, that means P is false. Then P is false. You might have recognized that this kind of looks familiar. If you're looking at an implication P implies Q, and that's true, if Q is false, then P is false. That is the contrapositive. That is the contrapositive. And the contrapositive here would be that not Q implies not P. And then finally, if the conclusion Q is true, well, that, based on the 3 rows that we're looking at, that could either be the first row or the second row. And the third row, I mean. And in the first row, P is true, but in the third row, P is false, which means I can't necessarily say what P is going to be. We are inconclusive about P. So just to recap, in general, if I have an implication P implies Q, which is true, I can only say something conclusively if P is true. In that case, Q has to be true. Or if Q is false, then I can say P has to be false. So let's do some more examples. Alrighty, so here is part B, which is saying if x is equal to 16, then y is less than -2. And keep in mind what the original was. That was saying if x is less than 15, then y is greater than or equal to -2. So the problem said that the implication P implies Q, this original one, is true. I'm just going to write capital T for true. But based on what we're given in part B, we're given that x is equal to 16. And if we're given that, that means the P portion, this is P and this is Q, that means the P portion is false. So P is false. And we just saw in that table that we made before that if our implication P implies Q is true, but the P portion, what we're given, if that's false, I can't make a conclusion about Q. So, let's write this better. So, we're inconclusive inconclusive about Q. So I can't necessarily say that y is greater than or equal to -2. It might be, but it might not be. So that means that y can be anything. Y can be anything. So we can't conclude that y is less than -2. So part B, this does not logically follow. This does not logically follow from the original statement that we had. All right, let's do another example, part C, which says if y is less than -6, then x is greater than 15. So for this, I want to give you a chance to try it. Pause the video for 2 minutes and try this one on your own. 4, 3, 2, 1. Pause it and try this one for 2 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 2 minutes. Okay, so again, we're given that P implies Q. This original statement is true, but we're given that y is less than -6. And that means that Q, which is saying y is greater than or equal to -2, Q is false. So that means based on what we're given here, Q is false. So when P implies Q is true, but Q is false, that means P is also false. That's the contrapositive, which we recapped in that table earlier. So P is also false. So thus, that means that x is not less than 15. X would be greater than or equal to 15. It's really important that I put that equal to sign. It's not just greater than. If x is not less than 15, that means it's greater than or equal to 15. So does that then let us say this conclusion, that x is greater than 15? Well, no, this does not. This does not. If x is greater than or equal to 15, that does not mean that x has to be greater than 15, because x could be exactly equal to 15. All right, so we could not reach this conclusion that x is greater than 15. So again, this does not logically follow. Does not logically follow, unfortunately. Alrighty, so let's do another example, but of a word problem that we'll have to translate to logic and then see the same type of thing. Will the conclusion, or will the next statement follow logically from the originals? Okay, so this example says, Naomi likes practicing early. Naomi vows that if Serena comes to practice early, then Naomi won't take extra serves and Naomi will bring food. Naomi always fulfills her vows. Suppose Naomi took extra serves. What can we conclude? Alrighty, so let's break this down a little bit. So we have this if-then statement, and it occurs here. It says Naomi vows something. So we'll come back and think about, well, what does it mean if she vows? Naomi vows that if Serena comes to practice early, then Naomi won't take extra serves and Naomi will bring food. So let me underline those keywords. There's the if, there's the then. But then after that, it says Naomi always fulfills her vows. All that means is when Naomi vowed that if Serena comes to practice early, so on, so on, so on, because she always fulfills her vows, that means the if-then statement is true. This means that the if-then statement is true. If the question didn't tell us this, that Naomi fulfills her vows, maybe she would have broken some of the vows. And then the if-then statement, we wouldn't necessarily be able to say that it's true. All right, so at this point, let's start by assigning some labels to the different propositions that we see here. So one of the things is Serena comes to practice early. So let's call that S. S is going to be Serena comes to practice early. Serena comes to practice early. And then after the then, there's something and something. Let me underline the word and. Something and something. And one of those things is Naomi won't take extra serves. So maybe let me call that E for extra. Say Naomi won't take extra serves. Won't take extra serves. And then there's this matter of does she bring food? And let me call that F. Naomi will bring food. Will bring food. So then we get that proposition or that sentence, once we translate it to logic, looks like, so it's if S happens, then two things are going to happen. Naomi will take extra serves, which is E, and, won't take extra serves, and F, which is Naomi will bring food. So one quick thing that I want to comment on is, if I had assigned E differently, and I said E was Naomi will, if E is Naomi will take extra serves, and then in this implication, I would be writing S implies not E. I would write not E to indicate that Naomi won't take extra serves. But it's also fine if I label my sentence like this. I could definitely let E be Naomi won't take extra serves. So because Naomi always fulfills her vows, that means this implication statement is true. So this is going to be true. And then the next sentence after that says, suppose Naomi took extra serves. So we are given, that's saying something about E, we are given that E is false because Naomi took extra serves. And because E is false, when I look at the and statement, E and F, if either one of those things is false, the whole and statement is false. So that means E and F, that whole thing, that and statement is false. Okay. So, because in this implication, the conclusion part of it, the E and F, that is false. This implies that the initial part, the given or the premise, S, is also false. S is also false. All right, so let's write our conclusion in words. The question was asking, what can we conclude? And what can we conclude? So S is false, which means Serena doesn't come to practice early. Doesn't come to practice early. Okay, so I want to box that. Okay, so notice that the very first sentence here, Naomi likes practicing early, that didn't really factor in to the overall structure of the argument. That was just sort of extraneous information. So we didn't actually use that. Sometimes that'll happen. Okay, so the other thing that I want to note about this is, in this example, E and F happen to be false. And that's what let us conclude that S was false. But if the E and F portion was true, then we can't conclude anything about S. We could not conclude anything. So finally, in terms of our goals for this section, we finished our last goal. We've looked at if-then statements and seen how we can determine whether another proposition follows from a given if-then statement.